Hello everyone. In today's presentation, I want to talk about the concept of break-even point and payback period analysis, which is the topic of our discussion from chapter 13 of your textbook. I will start with the concept of break-even point. What is a break-even point? Break-even point is the point at which you do not have any profit. It means your net profit is equal to zero. So when your net profit is equal to zero, it means that break-even point is a point that your total revenue is equal to your total cost. So with this brief introduction, let's just look at one example through together. Let's say we buy a machine for $200,000. Let's say you buy some sort of equipment or a machine for $200,000 that it produces parts which cost $500 per part. So you can sell each part for, let's say, $700. Each part for $700. So it cost me $500 to produce each part using this machine, and I can sell each part for $700. So the question that we are trying to answer is, after how many parts, after producing how many parts can I start making money? After how many parts can I start to see some sort of benefits or profit using this machine? So let's just look at what is happening in this scenario. I have a total cost. I have a total cost, and also I have the total revenue. Total revenue that we have, okay? So let's say, what is our total cost? When I look at this scenario, I have the cost of purchasing this machine as well as cost of producing the parts. So therefore, I can say my total cost is $200,000, which is our fixed cost. When I say fixed cost, it means no matter how many parts I produce. If I produce one part, I have to pay $200,000. If I produce 5 parts, I still have to pay this $200,000. Plus 500 times, let's say, X. It means that if I have to spend $500 to produce one part, if I manufacture X parts, I have to pay 500 times X. So as you can see, the second element of this cost function is our variable cost. The reason I'm saying it's variable because it's a function of how much you produce. The more you produce, you have to pay more. Your total revenue is equal to 700 times X. So again, as you can see, this option, this revenue is also a function of the amount that you produce. The more you produce, the more you can sell. Assume that you can sell whatever you produce. So generally, if I want to draw this cost and revenue functions, let's say this is the dollar axis and this one is a function of parts. So if I want to draw the first option, that is the total cost has a fixed cost element, let's say, for example, as a fixed cost is kind of like an intercept, then I have, for example, the slope of 500. So after that, the more I produce, I have to pay more for example, raw material, for any unusable items and so on. So this is your total cost function. It means that the more I produce, total costs, I have to pay more. The other cost function that we have is, the other function that we have is our total revenue. Total revenue is 700 times X. What does it mean? If you don't produce anything, you will not be able to sell anything. Can you make money? No, I cannot. So it will be zero if I don't produce anything. But if the more I produce, the more I can sell, and therefore I can make more money. This blue line over here is your total revenue. So the point that your total cost is equal to your total revenue, which is this red point over here, is the point that we call it as break-even point. This is the point that we call it break-even point. It means that the break-even point is the point at which your total cost is equal to your total revenue, is equal to your total revenue. So do you agree that we can define our total profit as total revenue minus total cost? And if they are equal, it means that our total profit is equal to zero. So let's say for this example that we are discussing, our total revenue is 700x minus our total cost. It's equal to zero. So it will be 200x is equal to 200,000. Therefore, our x is equal to 1,000 parts. So the point at which I don't make any money or I don't lose any money is your break-even point. That, for example, in this example, it's equal to 1,000 parts. It's a point at which I have no net profit. This is your break-even point. If you produce any number, any parts that are greater than 1,000, you will be in green zone. And if you're in the green zone, it means that you are making money, so you will have some benefits on this side. On the other hand, if you produce anything less than 1,000, for example, if you produce 500 units, if you produce 900 units, this is the area at which you will have your loss. Okay, so if I'm in the green zone, it means that I'm producing more than break-even point, so I will make money. I will have some benefits. Otherwise, if I produce anything less than break-even point, it means that I will lose money. So it will be our loss. And it makes sense because look at these lines. When you're in the pink zone, your black line, which is your total cost, is on top of the revenue line. And when you're in the green zone, your blue line is on top of the total cost. That was the concept of break-even point. So again, break-even point is the point at which your total profit is equal to zero. It means your total revenue is equal to your total cost. The next topic that I want to discuss is the concept of break-even point, and that is the concept of payback period. Payback period. So payback period, as it comes from its name, is the time that it will take to pay back your initial investment. Let's say I will get some sort of equipment, and I want to know how long does it take to recover that initial investment. So before I start talking about examples, I should tell you that we have two types of payback periods. So one approach that we have is the case that you don't have any interest rate or simply there is no growth. So if you don't have any interest rate, it means your I is equal to 0, which we call the scenario of simple payback over here. On the other hand, if your I is not 0, if it is any number that is not 0, if it's 1%, 10%, 12%, whatever, we call this as discounted payback period. So again, this is the time that it would take to recover your initial investment. So I will start with one example from simple payback period. So let's say if I spend $100 here, I want to know if I can make 70, if I make $100,000 here and I can make some money, let's say $75,000, 75 for n years, what will be the value of n when I is equal to 0%? It means I have simple payback period. So after how many years I can recover the initial investment? So we say negative 100 plus 75 times n, it will be equal to 0. Therefore, your n is equal to, for example, 1.3 years. It will take this much to recover your initial investment. That's the concept of payback period, and that's simple payback period. So as you can see, when you want to determine your payback period, there are different ways, but probably the easiest way is to determine the present worth, set it equal to 0. Your n is missing and you're looking for the value of n. So the other question that I would like to look at is this example that's again related to simple payback period. So say in drilling equipment costs $18 million right now. And it has, I would say, has an expected cash flow, CF of $3 million per year. Salvage value is $3 million at any time during its 10-year life. Its 10-year life period, lifespan. So the question is, when you have simple interest rates, simple payback period, it means when I is equal to 0%, determine your payback period. You're looking for the value of payback period. So you have spent $80 million to purchase it, and it has a cash flow of $3 million per year. Salvage value will be also equal to 3 no matter at what time you sell it. So let's just solve this problem.